The last item in discussing transformations of functions is to be able to come up with the equation for the graph of a function based off of the transformations from a parent function. So first step you want to do is you want to identify what the shape of this graph looks like from our parent functions. And we only have one graph of a parent function that looks like this, starting in quadrant 3, going up to quadrant 1, and that is our x cubed parent function. So what I need to do is I need to figure out what kind of transformations actually happen here. Well, x cubed does go through 0, 0, so I have no horizontal transformation, I don't have a vertical transformation, and I don't have any reflections from my x cubed graph. But this number 2, 2 is different than my original x cubed. Normally, when I put a 2 into the x cubed function, I normally get 8. So what we're going to end up is we need to come up with a scale factor that's going to take this and turn it into a 2. So what I'm going to rewrite this is f of x equals ax cubed. And I'm actually going to substitute numbers in on this side and then substitute the 2 in there, and I'm going to solve for a, and that's going to give me my function. Well, f of x, another name for that is y, and my y value is 2. 2 equals a times 2 cubed. Well, 2 cubed is 8. Divide both sides by 8. So that gives me 2 over 8 equals a. 2 over 8 is 1/4. And now I have my a. So my final function would be f of x equals 1/4 x cubed. So you write as much as you can about the transformation, and then you fill in numbers. This graph right here, it's problem 57a. It looks like the absolute value graph that has been reflected across the x-axis. So what I'm going to do is I'm going to write it as an absolute value function. I notice that the vertex of this absolute value is still at 0, 0, so there were no horizontal or vertical transformations. So what I'm going to do is I'm going to write f of x equals a absolute value of x. Notice I did not put a negative a in here because it's automatically going to be determined when I actually stick my values in for the function. Again, another name for f of x is y, so I put a y value in, -2, equals a times the absolute value of 4. Absolute value of 4, so that is 4, so that gives me -2 over 4 equals a. -2 over 4 simplifies to -1/2. So my final function, I take that -1/2 and put it up here, is f of x equals -1/2 absolute value of x. I can extend this to same type of rules to things that have horizontal and vertical shifts. So I am going to draw a parabola that has horizontal and vertical shifts. I'm going to shift it 3 to the left and 3 down. And I'm going to give you one more point on the function. And that point that I'm going to give you is at -2, -1. This is my x. This is my y. So what I do is I write the generic form of my function. So it's going to be f of x equals some sort of compression or stretching times something squared plus something. Well, let's figure out what these are going to be. Well, I shifted 3 to the left, so that would be a +3 here. I shifted 3 down, so that would be a -3 here. I am now going to take this point, substitute it in for x and y, and that is going to allow me to get the a for this function. Again, another name for f of x is y, so I get negative 1 equals a. My x value is negative 2 plus 3, quantity squared minus 3. Following order of operations, first thing I want to do is do this work. Negative 2 plus 3 is 1. 1 squared is 1. 1 times a is a. I add 3 to both sides. Negative 1 plus 3 is 2. And I get 2 equals a. I take this a and I put it back into that function, and my final function is going to be f of x equals 2 times the quantity x plus 3 squared minus 3.